In this video, we're going to be looking at angle measures and polygons with interior angles and exterior angles, as well as the sum and just one interior and exterior angle. So it's a very big vocabulary unit. It might help you to have a highlighter available so that way you can kind of look for key vocabulary words. All right, let's get started. So our goal today is to find the measures of interior and exterior angles of polygons. So a little bit of review. The sum of the interior angles of a triangle equals 180 degrees. This is something that we've used earlier this year. And the sum of the interior angles of a quadrilateral equal 360 degrees. We would like to draw as many diagonals as possible from one vertex. And we want to know how many triangles are formed. So right here you have a triangle, quadrilateral, pentagon, and hexagon with 3, 4, 5, 6 sides. This has got one triangle. This one, from one vertice, from one vertex, I can draw two triangles. From one vertex here, I can draw two diagonals, so that's going to make three triangles. And then the pattern will continue. So from this one vertice, one vertex, I have 1, 2, 3 diagonals, which will make 1, 2, 3, 4 triangles. And then if you recall, as we just said, the sum of the interior angles of one triangle is 180. So this is going to be just the 180. Here I have 180 degrees, another 180 degrees. So 2 times 180 equals the 360. Here 180, 180, 180. So I can add that up, or I can do 3 times 180. And 3 times 180 is 540 degrees. And then same thing here, 1, 2, 3, 4 triangles. So 4 times 180 will give me 720 degrees. So what would the sum of the interior angles of an n-sided convex figure be? So the sum of the interior angles of a convex polygon equals, if you notice, it's always this number, this number, this number. So if n is 6, I always feel like it's easiest to do with the largest number. So if n equals 6, we're going to subtract 2 from that to get the 4. 5 minus 2 is 3. 4 minus 2 is 1. 3 minus 2 is 1. 4 minus 2 is 2. I think I said that wrong. 4 minus 2 is 2. So you can kind of see that pattern. So it's going to be n minus 2 times 180. Okay, and I'm going to go ahead and highlight that. So this is the sum of the interior angles, and we're going to use that formula, n minus 2 times 180. And this is a formula that we're going to be using quite a bit in this particular unit. All right, so example 1. Find the sum of the interior angles of a convex octagon. So I'm looking for the sum, interior angles, and I'm looking for an octagon. There aren't going to be a lot of trick questions with vocabulary. So convex just means it's not caved in. This would be like a concave polygon. So convex is where you don't have any angles that are caved in. Okay, so here n will be 8, and octagon has 8 sides. So we're going to do 8 minus 2 times 180. Okay, so that'll be 6 times 180. So 6 times 180, and you're going to get 1080 degrees, so 1080 degrees. All right, I'm going to go over to page 2 now. We're going to kind of skip around to make sure you see a variety of different examples in this video. All right, on the top of page 2, example 3a, find the value of x. So first thing you need to know is this is a convex polygon. How many sides does it have? So the strategy that I like to use when I'm counting sides is I like to mark a side as my starting point. So this is my first side, and that way I know when to stop. So side 1, 2, 3, 4, 5. I have 5 sides. Okay, so now I'm going to do 5 minus 2 times 180, and we're going to get 540 degrees. We just did that in our chart. And now all of these angles together add up to equal 540. So I'm going to do x plus 114 plus 105 plus 102 plus 135 equals 540. We're going to add all those together. So 114 plus 105 plus 102 plus 135, you're going to get 456. So x plus 456 equals 540. So I subtract 456, and I'm going to get x equals 84. And that's an angle that I can get my head around. So it's between 0 and 180 degrees. You wouldn't want an angle to be more than 180 degrees, and certainly you wouldn't want a negative angle. All right, now let's go on to example 4. So I called this one 3A, and we'll save example 3B for office hours. All right, example 4. The sum of the measure of 7 interior angles of a convex octagon is 960 degrees. What is the measure of the 8th angle? The sum of the measures of 7 interior angles of a convex octagon is 980. What is the measure of the 8th angle? So I'm not going to draw a diagram to do this, but we have 7 out of the 8 angles. So I'm just looking for that one extra angle. So I have the 8th angle plus the sum of the other 7 angles is going to equal the total. So to find the total, we're going to do 8 minus 2 times 180. So when I do that, it's going to be 6 times 180, and I'm going to get 1080. I think we just did that one. So we're going to get 1080 for the right-hand side. I'm going to subtract 960. And when I do that out, I'm going to get 120 degrees. And again, that's an angle that makes sense to me. One interior angle certainly could be 120 degrees. All right, let's jump down to our next formula. There are several formulas that we're going to be looking at this week. If a polygon is regular, all interior angles are congruent. So I'm going to highlight that. And I'm just going to have us pause for a minute. I'm just going to write over here, let's look at a square. Okay, so if we look at a square, and I'm just going to draw a square. Okay, all 4 sides are congruent. That's my crazy dog. Hi, Jedi. Thanks for participating in our video today. All right, I have 4 angles, and I have 4 sides, so I do 2 times 180 to get 360. So now I'm going to do 360. And if you think about it, all 4 angles are going to be congruent. So I'm going to do the sum divided by 4, and that's going to equal 90 degrees. That will give me each angle. So we can use that always. So one interior angle of a regular polygon, one interior angle of a regular polygon remember all angles and sides are congruent, will equal the total, the n minus 2 times 180, so that's our new formula that we were just working on, divided by the number of sides. And this is a formula that we can use if it's regular. So you really have to watch out for our keywords. So I'm looking for interior versus exterior. We haven't started exterior yet, but we will. And then our formula here, since I just want the 1, I now divide by the number of sides. Okay? All right, so let's try example 6 here. The measure of one interior angle of a regular octagon. All right, well, we just did an octagon a few times, but just in case you forgot, 8 minus 2 times 180. We're now going to divide by the number of sides. So the sum of the interior angles of the octagon is going to be 1080. And now the only difference is it says one interior angle. And I'm going to go to a different highlighter color here. So I want one interior angle, and it has to say the word regular. Okay, you won't see trick questions, but it has to say regular, meaning all of the angles are the same. And then you would just do the 1080. See, we just did that one a minute ago. So 6 times 180, just to review, and then divide by the number of sides, which is 8. You're going to get each angle in that regular octagon is 135 degrees. Okay, what I'd like to do now is we're going to go to the top of page 3. All right, and we're going to now start looking at our exterior angle. So the first thing that you need to know is, what is an exterior angle? So the exterior angle are these angles here. Okay, and what I showed you here is a pentagon. So the number of exterior angles equals the number of sides. Okay, so if you have a 5-sided figure, you have 5 exterior angles. You also have 5 interior angles. That's always going to be the same. If I went through the chart, I could prove that the sum of the exterior angles of any convex polygon equals 360, but I'm not going to do that today in this video. We're just going to accept that as fact. So the sum of the exterior angles equals 360. Okay, and maybe that's something that we'll talk about in office hours, but we're looking at just the sum of the measures of the exterior angles. So actually question 8, it's not even a formula, it's just a fact. So for question 8, the sum of the measures of the exterior angles of a convex 18gon is 360 degrees. So that's just saying if I had an 18-sided figure, if you have all those 18 sides, it's going to start to look more and more like a circle, but you're just going to be adding up all of those 18 exterior angles. It always equals 360. Okay, so you're going to get 360 degrees, and that's pretty straightforward. So now let's go on to example 10. Find the value of y in the convex polygon below. So this has got 1, 2, 3, 4 sides. So 4 sides. So this is a quadrilateral. Okay, and now we're looking at exterior angles. So all of these are going to add up to 360. So I'm going to do kind of the same thing that I did with the interior angles, where I just took each one and added them together. So y plus 2y plus 2y plus y equals 360. I combine my like terms. 1y plus 2y plus 2y plus 1y. 1 plus 2 plus 2 plus 1 is going to be 6y equals 360. So I solve by dividing by 6, and I'm going to get y equals 60. All right, so now let's move on to page 4. All right, so in page 4, the measure of each exterior angle of a regular polygon with n sides. Now this shouldn't be a surprise to you. So if I want each or one, I can put a little arrow here and say 1 exterior angle, I'm going to do the same thing that I did with the interior angles. You're going to take the sum and divide by the number of sides. So I'm going to highlight that. Each or one exterior angle has to be regular. We're going to do 360 divided by n. So the exterior angles, the formulas are a little bit simpler. So just remember the sum is 360. Anytime you want one angle for interior or exterior, you just divide by the number of sides, which is n. So let's take a look at example 12. Find the measure of one exterior angle of a regular octagon. So we are exterior angles, and I want one exterior angle. One exterior angle. Doesn't even matter how many sides it is. So since the sum equals 360, anytime you want one, oh, it does matter because that's going to tell me n. So here, n equals 8. That did matter. So I have the sum equals 360. I'm going to divide by the number of sides, which is 8, and that's all that I need to do for this question. So I have 360 divided by 8, and I get 45 degrees. So it's a pretty quick calculation. The hardest part is reading each question for information. So I really would encourage you to highlight your work as you go along. All right, I am going to jump down to example 5. Find the measure of each exterior angle of a regular the measure of an exterior angle of a regular octagon is x plus 10. Find the value of x. So I have to really read it carefully. So this is saying one exterior angle is x plus 10. Find the value of x. Well, because it's an octagon, n is 8, and we can find each exterior angle. Actually, we just did that, right? Because we just did that and we said 360 divided by 8 and we got 45 degrees. I'm also saying that that exterior angle is x plus 10. So once you find each exterior angle, which is this, you can set it equal to x plus 10. So I'm just going to subtract 10 and x will equal 35. Okay, so we find one exterior angle, I set it equal, and then I'm all set. All right, we're going to go on to our last page for notes today. So that's going to be page 5. All right, and now we're going to be doing some kind of application questions a little bit. So I'm on the top of page 5 here, example 17. And again, look for those keywords. So the measure of an exterior angle of a regular polygon is 30 degrees. How many sides? How many sides does a polygon have? So I'm looking for n. Okay, I'm giving you one. So one angle is 360. One angle is 360. So what you should do for these questions, if 360 divided by n, if 360 divided by n equals one exterior angle, then you can do 360 divided by one exterior angle to get the number of sides. And that's a very, very easy calculation. So you're given one exterior angle. So I'm going to do 360 divided by 30. And you're going to get 12. And that tells you you have 12 sides. So I do like to label these. So if you get confused, it helps you to remember what's a degree versus what's a side. And then if you think about it, if you reverse it, 360 divided by 12 will give you the 30 degrees. So you can kind of go either way. So the last question we're going to do today is kind of the same question. We're going to do example 19. The measure of an interior angle of a regular polygon is 150. How many sides does the polygon have? So n equals, so I'm looking for the number of sides. Well, I can show you two ways to do this. The easy way is to change it to an exterior angle. And guess what? We just did that. So if you think of your polygon, this is 150 degrees. It's one interior angle. That means my exterior angle, be ready to be blown away. These make a linear pair. So you would do 180 minus 150, and you're going to get a 30-degree angle. That's the trickiest part. So now I have one exterior angle is 30 degrees. Does that look familiar? One exterior angle equals 30 degrees. And guess what, folks? We just did that. It's the exact question that we just did in number 17. So then we would do 360 divided by 30 and get our 12 sides. That is the easy way. So the easy way is to change it to an exterior angle, and you do 180 minus the angle when you do that. 180 minus the angle, because that's the linear pair. And then you're going to do 360 divided by the exterior angle. And if you want, we can highlight that up here. So anytime you do 360 divided by one exterior angle, and you get the number of sides. Alternatively, and I will show you this, but it's pretty challenging, we would say n minus 2 times 180 divided by n. I wouldn't write this down, and I wouldn't do it. Equals 150 degrees. At this point, I would make it a proportion, and I would do n minus 2 times 180 equals 150n. And then from there, you're going to distribute. So 180n minus 360 equals 150n. All right, and then I would add 360 to each side. See how this is a lot of work? And I would subtract 150n from each side, so that way I have a positive. So when I subtract, those cancel, and I get 30n equals 360. Well, wait a minute, I had that way at the beginning, because now I just divide by 30. And now n equals 12 sides. So mathematically speaking, it is perfectly fine to use the formula for one interior angle equal to the 150, but I don't advise this because this is a lot of computation. When if you just switch it to an exterior angle, it becomes a question like number 17. You subtract the angle from 180 to get the exterior angle, do 360 divided by that number, you get the number of sides. So to summarize, there are basically four concepts. The sum of the interior angles of a convex polygon is n minus 2 times 180. If you want one angle, you divide by n. The sum of the exterior angles of a polygon equals 360. If you want one angle, you do 360 divided by n. Thanks for watching, and I hope this helps. Have a great day.